Hi guys, welcome to our fourth video of the Computer Lab session for Dr. Yan's class. In last video, we do a two-tail test, and in this video, we are going to continue the hypothesis testing by doing the one-side right-tail test. For one case, it's going to be using the hypothesized value is equal to 0, and for another case, we have with a non-zero hypothesized value. So let's start by the testing the hypothesis that whether the IBM outperformed the market. In other words, we are going to test the null hypothesis that the intercept is smaller or equal to 0 against the alternative hypothesis that the intercept is greater than 0. Again, like there are two approaches. One is to comparing the test statistic with the critical value, which the critical value is going to be computed using the quantile function Qt. And for the second approach, p-value approach, we are going to compare with the significance value, which the p-value is going to be computed using the PT functions, which if we set the lower dot tail equals to true, is going to give us the PDF. But if we set the if we change the argument lower dot tail equals to false, it's going to give us the probability of the right side rejection, the shaded area on the right tail. And times 2, we will get the in this case it's right tail, so we just keep the right tail probabilities. So yeah, let's get started. So for test statistic approach, like the critical value is a bit different because this is a right tail test, right? A 95% right tail test is we're going to calculate the threshold of the 95% instead of a 97.5%. And the degree of freedom is 196, as is reported by the regression result. Here. So if we compute the critical value and then we report it with the test statistic, we can clearly see that like the test statistic is not larger than the test statistic, so we cannot reject the null hypothesis that the population the intercept is smaller or equal to 0. In other words, we cannot. Sorry, I want to rephrase it. Because like this is false, right? We cannot reject the null hypothesis that the intercept is smaller or equal to 0. In other words, we cannot say IBM outperformed the market. And from the p-value approach, we're going to compute the probability of the right tail, and again, like using by providing the test statistic, the threshold, we compute as the first argument, and then degree of freedoms, and set lower dot tail equals to false, because otherwise it would be CDF, and in fact we want the shaded area of the right tail, right? And then we compute it, and then because this time it's just the right tail, one side only, so we do not need to times 2, and you can see that like the p-value is still way larger than 0.05%, and hence we cannot reject the null hypothesis at 5% significance level. And in this, in other words, again, like we cannot reject the null hypothesis that the intercept is smaller or equal to 0, and hence we cannot conclude that IBM outperformed the market. So this is the first right tail test we in this video, and for the second right tail test, we are going to test whether IBM is an aggressive asset. So it's basically means that we are going to test the null hypothesis is the beta 2 smaller or equals to 1 against the alternative hypothesis that beta 2 is greater than 1. So we have a non-zero hypothesized value this time. Again, like we recall that the coefficient regression result. Like this time, we want to do the beta 2, right? So it's the second row. So we want the second row first column as the coefficient the coefficient estimate of the SPX, and then standard error of the SPX as the second row, second column, and then hypothesized value is 1 this time, and we get the test statistic. Because like this is non-zero, so we cannot use the because the hypothesized value is non-zero. So this time we have a test statistic that not the that are not the same as the one reported by R, and yeah. So if we compare against the critical values, we can see that like we cannot reject the null hypothesis, and therefore like we cannot reject the null hypothesis that the beta 2 is smaller or equals to 1, and hence we cannot conclude IBM as an aggressive asset. And oh, sorry, I still forgot the p-value approach. And for the p-value approach, again, we are going to compute. We are going to use the CDF functions, but setting the lower dot tail equals to false, and hence is 1 minus CDF, which is the we'll get the probability of this. So providing the test statistic as the first argument, and degree of freedom is equals to 196, and set the lower dot tail equals to false, we get the shaded area in the right tail, and we don't need to times 2 because this is not a two-side test, and then the p-value is 0.458, which is still way larger than 0.05, and hence we cannot reject the null hypothesis. And yeah, that's it.